Okay, so the last two that we had was A and B at the end. Okay. So this one is similar but a little different. Solve the following differential equation. So differential equation, that's the first time we've seen the word differential, or the phrase differential equation. It just means derivative equation. So they give you the derivative equation, okay, with given conditions. So for A, there's a first derivative, and the first derivative is 3x minus 1. And on the original, on F, when x is 2, y will be 3. That's a condition. Okay? So what they want us to do is find the original. So they want us to find f of x. Well, if they've given you the derivative equation, the differential equation, and they want you to find the original, that's antiderivative. Okay? So we got to do antiderivative for 3x minus 1. So remember, the rule, or the power rule for antiderivative said add 1 power, divide by that new power. So this would be 1x to the first over 1. So in other words, it's 3 over 2 x squared minus x. And then plus c, right? Remember plus c? So that's f of x. But they want us to be a little more specific with it. That's called the general, because it has the c. The general f of x. They want specific, and that's where this guy comes in here. So this is on the original. When I plug in 2 for x, I should get 3 as an answer. So what I'm going to do to the original is I'm going to plug in 2. And when I plug in 2, it said I should get 3 as an answer. Well, that way there's only one variable left. It's c. Solve for c. We can solve for c now. Okay, so I get 3 over 2 times 4 minus 2 plus c. So we got to do multiplication first. So 3 over 2 times 4 over 1 is 12 over 2, which is 6. 6 minus 2 is 4. Solve for c. So in this case, c is going to be negative 1. So we're going to take the general solution that I had before and make it specific to this problem. So when if x is 2 and y is 3, that means c has to be negative 1. Okay? When they give us that condition, this is the condition here. When they give us the condition, we can be more specific with our answer. We don't have plus c. Plus c is when we can't be more specific. Okay. Okay. All right, so let's do one more, and then I'll let you guys work on your own. Okay, so now B. Start with, now they've given us the second derivative. The second derivative is 2. So the first thing I have to do is find the first derivative. Well, use the power rule. Oops, not 2. Not divided by 2, divided by 1. So it's really just 2x plus c. But they've given us a condition for the derivative. They said, hey, for the derivative, when you plug in 4 for x, you're going to get 0 as an answer. So I'm going to plug in 4 for x, and I'm going to get 0 as an answer. So I get 0 equals 8 plus c. Solve for c. The specific differential equation, or derivative equation, is 2x minus 8. I'm not there yet, though. I need to find the original. So I'm going to do the same thing. So if I was to find the original, I would use the power rule again. So I'm going to add a power, divide by that same power, add a power, divide by that same power, plus c. So the original is x squared minus 8x plus c. But the condition for the original is here as well. On the original, when x is 4, y is negative 1. So I'm going to plug in 4 for x, and negative 1 should be the answer. So I get 16 minus 32 plus c equals negative 1. Negative 1 equals negative 16 plus c. Add 16 and you get, c is 15. So I'm going to go back to the original that had c in it. And now I know that c has to be, for all of this, for those conditions to be true, c has to be positive 15. And there's the original. Now you can only do that if they've given you the conditions. These were the only ones that gave you conditions. On the first 3 pages, they didn't give you any conditions, so we had to leave plus c. But these, they've given you some conditions. They're called conditions. Okay. All right, and that's it. That's antiderivative. So just using the power rule. We're just using the power rule for everything. Either you're using the power rule or you're using one of the trig things, one of these guys here. Okay? You can't use a product rule. You can't use a quotient rule. You can't use the chain rule. There's none of those yet. So just the power rule that we've talked about.